In this video, we'll discuss linear classifier training. Our total loss or cost function for logistic regression looks something like this. It looks pretty similar to linear regression, except we have that little logistic term. We can do a simplified example where we'll only look at the bias term, and we'll also look at how the threshold function behaves, because it's a little easier to understand. So let's take a look at the threshold function. So let's look at the total cost or loss in the threshold function. We currently have 3 misclassified samples, and these are misclassified samples. We calculate the loss for these 3. It's the following. If we calculate the loss for these 3, it's 0, because they're all classified correctly. Total cost is 3. If we move the line a little, we'll only have 2 misclassified samples. And if we move it a little further, we'll get perfect classification. Of course, like linear regression, we can go too far, but we won't worry about that for now. So if we look at the cost function with respect to the bias, you see here we have 3 misclassified samples. So if we move the line a little over, and we perform gradient descent, the derivative is 0. And the reason is, if you look at the cost function, the values are either 3, 2, or 0. If you wiggle the line a little in any direction, it won't really change. Now, if you look at the cost function for logistic regression, it's a lot smoother and flatter. So let's say we're at this point. Look at the loss generated by the following sample. Now let's look at the loss generated for that sample. So let's say it's about 4.99. If we move the line a little, the value for the logistic function will change slightly to 4.88. But it's still enough to give that nice little curve we need to perform gradient descent. So when we perform gradient descent with the logistic function, we're a lot less likely to get caught in those little flat points. But we can still overjump like linear regression. So let's look at the cost or total loss surface for logistic regression. So if you look at the loss surface, we see there are a lot of contour lines this region, but no contour lines in this region. So that implies a flat surface. If we start a random initialization in a good location, let's say over here, our algorithm will converge to a minimum. But if we start our initialization over here, nothing will happen.